For this example, we want to solve sine times tangent equals sine on the appropriate domain. So here, starting from what we have, I'll say it's not entirely clear what might be the next best place to go, but we want to isolate our trig functions on one side, so let's bring over that sine and maybe we'll see something a little nicer. Because sine and tangent do cancel, but not in this way. So we'll bring over that sine and we'll have sine tangent minus sine is equal to 0, and then from here, we don't have cancellations, but we do have too many sines, so we can pull a sine out of there and rewrite this as sine times tangent minus 1 is equal to 0. Doesn't tell us a whole lot by itself, but we can see from here that we have two ways to satisfy our equation. Either we can have that sine is equal to 0, or we can have that tangent minus 1 is equal to 0. That is, sine of x can be 0, or tangent of x minus 1 can be 0 if you prefer. Tangent can be 1. Well, these give two separate types of cases that can satisfy our equation then. In order for sine to be 0, you may remember from earlier on in chapter 4, this happens at some of those quadrantal angles, specifically the ones occurring along the x-axis, because along the horizontal axis, the vertical component can't be very large. That is, on our predetermined location, x is equal to 0 or pi. Meanwhile, tangent is equal to 1 at those values where the unit circle hits the line y equals x, which occurs at places like pi over 4 and also 5 pi over 4. So this gives us our 4 solutions on the given interval to our equation. Either x is equal to 0, pi, pi over 4, or 5 pi over 4. Any of these will satisfy that equality. And next, what we're going to do is look at how we can do these sorts of things using identities. So we talked about some algebra, some basic trig. Now we're into stuff that's a little bit more advanced, but hopefully not too far out of bounds.